All right, I think I'll kick us off. Hello, everybody. Thank you for joining today's webinar titled Validating the Aftermarket, PEMS in Action. I'll be your host today. My name is Dean Schlingman. I'm the Director of Emissions Compliance here at the SEMA Garage. So during today's presentation, we're going to take some time to share some of our knowledge about PEMS systems and why they should be considered as a development tool in your quest to achieve emissions compliance. During the presentation, please feel free, send some questions that come to mind. You can do that with the chat option. We'll do our best to cover those at the end of the presentation. Our first presenter today is Dr. Alberto Ayala. Dr. Ayala is a mechanical engineer with a bachelor's, master's, and PhD from University of California, Davis, and he is author and co-author of more than 160 publications and reports. Dr. Ayala is the Executive Director and Air Pollution Control Officer of the Sacramento Metropolitan Air Quality Management District and former Deputy Executive Officer of the California Air Resources Board. Dr. Ayala is author of the upcoming book, Three Forks in the Road, Dieselgate, the Volkswagen Cheating Scandal. Our second presenter is Matt Berry. Mr. Berry is responsible for development of 3DADX business in Europe. Matthew is an engineering physicist from the Royal Military College of Canada, where he was commissioned as a naval officer. He also has a master's degree in business administration from Group HEC in Paris. And then our third presenter today will be Dr. Daisy Thomas. She is the lead engineer for 3DADX Corporation. Her role focuses on the function, development, and application of the 3DADX parsing to IPEMS. Her most recent research has been based around inspection and maintenance programs. Daisy has over 8 years experience in automotive engineering research with a PhD in engineering that focuses on vehicle emissions from the University of Leeds, UK. So I added this quick reference guide to make certain we're all using the same definitions for emissions development hardware. This is sort of the definitions slide, and then we'll move on. In this slide of illustrated technologies available to us, starting with a simple oxygen sensor on the left. It's relatively low cost and related data output and accuracy. As you can move towards the right of the slide, the technology options become increasingly more accurate, reporting more types of useful data with associated cost increases. So today, we're going to focus on the third technology column, which is PEMS, and that's short for Portable Emissions Measurement System. If you see us reference IPEMS, that just means integrated PEMS, which could be something that's integrated into other data link systems. It kind of depends what your system is for testing. So at the conclusion of the presentation, our hope is that you'll have a firm understanding of the opportunities this type of a tool provides and how it can be used before sending your product into the laboratory for testing. We know that's an expensive endeavor, and if we can offer up tools and knowledge that can reassure you or add confidence to what your results are going to be, that's exactly what we're trying to do here by introducing this technology. So without further ado, I'm going to introduce Dr. Ayala.
Excellent. Well, thank you very much, Dean, and thank you, SEMA, for the very kind invitation. It's a pleasure to be here with you all and share a little perspective in terms of some of the policies that have gotten us here with respect to PEMS. PEMS is a concept that has been around for some time, and it's great for all of us to get together and contemplate, as Dean said, some of the great potential that the technology has achieved. And I think it's great to have our friends and colleagues from 3DADX because their technology is one that represents how far we've come. We've been at this for a couple of decades at least. So it hasn't been quick or easy, but we've come a long way. And my hope is to give you all just a little perspective in terms of, at least from the California perspective, what role and the expectations that policymakers have with respect to the technology. So we'll get into a little bit of that. Next slide, please, Steve. So I think just to ground set, the first thing that we need to recognize is when it comes to air pollution and air quality around the United States, and I would imagine this would apply to many other places around the world. We've made a lot of progress in terms of air quality. Obviously, our fuels have gotten cleaner, our vehicles have gotten cleaner, our equipment have gotten cleaner, but we're not there. And for reference, I actually want to point you to this great report that the American Lung Association puts out every year. Um,
Is he frozen, do we think?
Yeah,
What?
it looks like we lost him.
Okay.
All right. Tell you what, maybe we can we'll come back to Dr. Ayala as soon as he's back on. Maybe we'll forward to Matthew in the meantime.
Well, here we go. So I'm Matthew Berry. I'm General Manager Europe and responsible for technical and commercial development at 3.x. Next slide, please. And I'm here to talk to you about an IPEMS, which is definitely not a 5-gas, but it's a portable lab quality instrument. The IPEMS equipment provides extensive utility and a range of applications in the developing requirements of periodic technical inspection in the US. That would be inspection and maintenance programs, and other emissions testing where we're working on programs to quantify carbon reduction. Our latest iteration is called the ParSync Flex. It has the following properties. It's small, it's lightweight, even with fully equipped with batteries for mobile operations. It'll run for 4 hours on a set of batteries. Obviously, it runs indefinitely if you hook it up to mains, but you can also hot swap the batteries and it'll run forever as well. Next slide, please. These are all the bits and pieces that come with a PEMS setup. We have the laptop for monitoring what's going on. We have the main unit with all the sensors inside it. We have a conditioning unit that removes condensate and volatile particles. We've got the miniaturized sensor cartridges, got the gas transport lines, the probe, power supplies, batteries, etc. Next slide, please. So the main sensor unit you can see here with the 3 miniaturized sensor cartridges that are put in there. The advantage of this is when they get dirty or damaged, you can swap out a sensor cartridge very quickly and carry on testing. The C cartridge has CO2, CO, hydrocarbon, and oxygen. N cartridge in the top has NO and NO2. And the particulate cartridge measures PN and PM. You can also see there's one battery position in the main module to ensure that there's no power loss. Next slide, please. These are details on the sensors. The type, where the NO and NO2 are electrochemical sensors. We give the measurement ranges, response times, tolerance, and the relative tolerance. Then we've got the CO, CO2, HC, which are based on non-dispersive non-dispersive infrared measurement, NDIR. Same characteristics listed. The oxygen sensor, which is also in the C cartridge, is an electrogalvanic for measuring, obviously, the oxygen. And then we have the PM cartridge, which has 3 sensors that vary in size of particles that they detect, ionization being extremely fine, opacity being in the middle, and scattering for the large size particles. With a measurement range between very small and very big, it has all of the sensors together have similar response times so that the curves overlay very nicely when you're recording rapidly changing response during a test drive. Next slide, please. So the conditioning unit, the cube, removes the water vapor by cooling the sample down to 5 degrees, and it also removes volatiles by heating the sample up to 370 degrees. 5 degrees being in centigrade, so it's above 0, and 370 degrees being very hot. There are 3 battery positions in the cube for mobile testing. Next slide, please. The PEMS is run on a CAN backbone, which is a very powerful communications network that allows us to connect many different auxiliary modules for real-time logging at 1 Hz frequency. We can acquire selected ECU parameters from the vehicle through the Bluetooth OBD adapter. We record vehicle position and the ambient pressure, temperature, and humidity conditions through our GPS weather station. If ammonia is something that needs to be monitored, we can hook in a very accurate LGD instrument. We can record fuel flow, and many different exhaust flow meters can be hooked in. So we're agnostic. Then, if it's important to measure temperature at different points in the exhaust after treatment system, there's multiple options of where you can hook in thermocouples. And if other instruments are required to be hooked in, or if the instrument needs to be hooked into another system, it is possible through the CAN bus backbone. Next slide, please. This is an example of a test setup. You can see, in fact, this is my car in London, England. Daisy, who is the next speaker, was around for this test, but she's not quite visible in the photograph. The PEMS or ParSync Flex is shown in the trunk of the vehicle, and it's sitting on the control unit for a Semtech exhaust flow meter, which you can see hooked into the exhaust pipe of the car with all its control cables. Next slide, please. The testing, which is performed on vehicles or generators, anything with a internal combustion motor, one of the first important parts of any testing program is to define the testing protocol. It is important before you start a test, obviously with warmed up equipment, is to zero for the local conditions. Every day, every different place will have slightly different conditions, so it's important to perform a zero of all the sensors. Then, it's important to measure the background conditions. We measure through a HEPA and we measure ambient air to get good zero with the particulate measurement and to get a good zero with or measure the background conditions of the gas sensors. Then, whatever the protocol is, whether you're measuring idle or you've got a drive test of different sections, we like to measure idle before and after the drive test, usually for a minute. And then when we finish and have shut off the engine, it's very important again to measure ambient air and to measure zero particulate background so that we can determine if there was any drift during the test and be able to correct for it if it did occur. So now that we've acquired all this data, what do we do with it? What good is this data? So let's move on, and Daisy's going to present to you case studies that have been done with these instruments.
Dean, are you happy for me to present, or would you like Alberto to complete his?
Why don't we continue down this path, and we're going to circle back around to Alberta.
Okay, cool. All right, so I'll be presenting just a couple of case studies today of times when we have been able to implement the IPEMS in testing in vehicles. So I will ask you to please go to the next slide. Thank you. So the main trial that I'll be talking about today was a trial of an enhanced inspection and maintenance procedure, which we conducted in partnership with Opus Sweden, who are inspection and maintenance, or what we in the EU call PTI, testing company. So what happened was, over the course of a campaign, we had one technician at the Opus, at a specific Opus site, who was trained to use the IPEMS equipment that 3Datix manufactures. And then what he did was he asked members of the public who were just bringing their car in for their regular PTI test, which is an annual test in the EU, if they minded if he performed an additional testing on the vehicle at the same time. So what happened was the vehicle was having some of its safety checks done, and during this time the IPEMS would be warmed up and zeroed, as Matthew mentioned in the previous section. The equipment would then be placed into the boot of the car when the vehicle was ready for its emissions test, with the sample probe placed at the tailpipe and an OBD logger placed at the ECU port. And then the vehicle was ready to perform its both its regulatory emissions test and the additional test that we designed on top of that. Next slide, please. So the protocol itself, as mentioned, integrated the standard PTI emissions test. So what happened was the vehicle would exit the garage at point 1 in the figure where you can see, and it would undergo a 60-second idle test before being driven to the emissions shed where its regulatory PTI test was performed. And in the EU, for petrol vehicles, this is an idle and high idle carbon monoxide and hydrocarbon test. And for diesel vehicles, this is a free acceleration smoke opacity test. And during the course of this testing, we also had the IPEMS running, so we were able to measure the other pollutants as well, which we were have an interest in. After this emissions test was performed, the vehicle was then driven along the dashed line past point 4 to the beginning of what we call the dynamic acceleration drive test. And that was a smooth acceleration up to 30 kilometers per hour and then back down to a standstill along the solid green line outlined as 0.5 on the figure. After this was completed, the vehicle was then driven back to the garage, so 0.7, where a final idle test was performed on the vehicle. And by comparing the idle test at the beginning of the protocol compared to the end, we were able just to check that the vehicle had been sufficiently conditioned before testing. Next slide, please. So over the course of the campaign, which took place over a year and a half, Stefan, the technician, managed to test 606 light-duty passenger vehicles. These were of varying model age, from 3 years when the PTI test first has to be performed on the vehicles, through to about 25 years of age, with some outliers being of even greater age. These vehicles had odometer readings going from about 20,000 kilometers through to 450,000 kilometers, and were of engine size from about 0.5 through to 3 liters in general. Next slide, please. So using the results of such a large campaign, we were able to infer some fleet emissions characteristics, which I won't spend too much time on in this presentation now, but I just wanted to show some figures where when you plot linear regression lines of best fit on the data, you're able to see some patterns. So looking just at the graph on the left-hand side, this is the NOx emissions from the dynamic drive acceleration test for the diesel vehicles that we tested. And on this, each dot represents one vehicle that we tested, and they're divided into the Euro 6 vehicles, so the newest vehicles in green, the Euro 5 vehicles, so slightly older vehicles, in blue, and the Euro 4 vehicles, so older still vehicles, in red. And in the EU, it was really the Euro 6 regulations that forced manufacturers of diesel vehicles to incorporate selective catalytic reduction into their emissions abatement technologies. And what we think that we can see with the fact that this line is showing some gradient compared to the earlier Euro standards is some effects of degradation of SCR catalysts as the odometer reading, so the mileage increases as we go on towards the right on the figures. Next slide, please. I also wanted to draw attention to the ability to identify high emitters on the PTI test. So there was one vehicle that was brought in with what is called a KCR box installed in it, which is basically a after-treatment technique that is meant to increase the power and torque from the engines, but is illegal in Sweden, where the testing was performed. And if we look at the next slide, we can see the effects that this technology had on the emissions. So here, because we had such a large campaign, we were able to compare this one specific vehicle against similar vehicles. So here in the bar charts, we have the various test results from different 2.4 litre diesel Euro 5 Volvo vehicles, which was the same as the model that had the KCR box installed on it. And in the red circles, we can see that this was the vehicle that had the highest emissions of NO2 and particle number during the campaign that we conducted. So you can really see here how a modification can really increase the emissions from these vehicles. Next slide, please. But on a brighter side, we were also able to investigate how a vehicle can have its emissions behavior improved. So we also did a different study where we had 2 different vehicles, and for each of the vehicles, we measured them before they had their 3-way catalysts replaced, and then after they had this 3-way catalyst replacement performed. And what we can see looking at the NOx emissions, the carbon monoxide emissions, and the hydrocarbon emissions going from left to right on these figures, on both the drive test on the top row and the idle test on the bottom row is that in each case, the pre-repair emissions concentrations were much higher than those after the vehicles had had their three-way catalysts replaced. And so this is just to show that this sort of pre and post change comparison can be used to check the emissions impacts of modifications to a vehicle system, such as changing of parts. Next slide, please. So hopefully in these few slides that I've shown today, I've shown that it's possible to conduct short emissions tests on a wide range of vehicles. And these have been able to demonstrate that the test can be conducted relatively easily and cheaply, and with low costs of equipment maintenance and time requirements. As you recall, the test that we performed in the first campaign that I mentioned only added 5 minutes onto each vehicle's inspection and maintenance procedures. And in doing this campaign, we were able to look both at the whole fleet and individual vehicle emission characteristics. We were able to identify high emitters amongst the test fleet, and we were also able to assess emissions impacts resulting from changes or alterations to individual vehicles and changes to the parts. So we thought that this type of testing could also be very useful for minimizing the emissions impacts resulting from vehicle aftermarket modifications as well. Thanks.
All right, thank you, Matthew and Daisy. I'm going to circle back around now to Dr. Ayala's presentation. I think it's important that we understand the why behind a lot of what we're doing here when we talk about PEMS and emissions testing. So I'm going to kind of rewind back to that place in time. I think this is about where you were.
Thank you, Dean, and there you go. Thank you. Actually, yeah, I was reflecting that this is actually, I think, gonna work out quite well, because now that you've heard those two excellent presentations by Matthew and Daisy in terms of the very significant capability of the technology, we'll circle back and maybe give you a little feeling for why we have PEMS, and what can you do by utilizing that technology that has come a long way. So again, apologies, technology is sometimes still a challenge, but anyways, the point I was trying to make here is we have made significant progress in around the world, for that matter, but I'm using the example of the United States. We have made significant progress fighting air pollution, but we're still not there. And the significant contribution that the American Lung Association is making on a yearly basis is to publish this State of the Air report. And basically, they look at all of the air quality monitoring information that air agencies collect across the United States. And they give us a report card. And without getting into the detail of the figures here, you've got results for two very important pollutants: particulate matter in the ambient air and ozone in the ambient air. And what you see here is that there's a number of cities in California that are exceeding what we would call the ambient air quality standards for clean air. We're not the only place in the United States that you can see, but some of the worst air pollution, it is still indeed in our state. Next slide, please, Dean. And I think that is important to recognize, because many times you may think, well, why is California so aggressive with its emission standards? And it is because that air pollution problem persists. Now, obviously, we also have a significant understanding where that air pollution comes from. And trucks and buses and vehicles and equipment are not the only sources, but they happen to be the largest source of air and climate pollution. And that is the reason why there's such a significant emphasis and interest in lowering the emissions that come out of tailpipes from vehicles, for example. Next slide, please. I think one important point to recognize is that the state of California has been at this for a while. And not by choice, because I often say it's out of necessity, because the air pollution problem associated with vehicle emissions was not only first discovered in California, but also it manifested itself. I have here on the left a picture from the USC archives in terms of what it used to be like in Los Angeles. For those of you that recognize it, that building in the background is actually City Hall. And it really was an issue where residents were demanding action from governments. And that is the reason that air agencies were first organized and implemented in California and so on. And the key point here is never mind the levels, never mind the details, but what I want you to appreciate is the trend line, that over the years, as technology has improved, vehicles have gotten much better, fuels have gotten much cleaner, and our ability to understand those emissions have gotten better. You see that there is a trend down in terms of the standards pushing technology to get cleaner. And when you consider that over these 62 years of standard setting in the state, we have almost eliminated, if you will, the emissions coming out of tailpipes. I think if you do the math, it's been 99.75% reduction, which is just an amazing amount of progress. And again, kudos to the car makers and the fuel makers that have brought the technology so that we all benefit from it. As the car fleet has grown significantly, if you think of how many cars we had on the road versus the 30 millions we have today, obviously there's a lot more driving and a lot more people today, and yet we have seen this tremendous improvement. Next slide, please. So now let's get into the regulations, and one of my tasks here is to kind of give you a little sense in terms of why do we have regulations, and what is the role of regulations. The standards are set in regulations, and these are legally binding. Every automaker that wants to sell into the California market and into the market of the states in the U.S. that have they have chosen to adopt the California standards, they need to comply with these limits. And it's actually rather simple, because for us regulators to be able to adopt a standard in terms of vehicle emissions, you have to do two simple things. One is you have to demonstrate that the emission limits can be met and are technology feasible, meaning there is technology on the vehicles that can actually meet the standards. And the other thing, obviously, is a positive cost benefit. The technology, the approaches that the regulation is pushing need to be shown to be cost effective. Let us not forget that the primary emphasis is typically tailpipe emissions, and PEMS are basically getting at tailpipe emissions, but there's also interest in evaporative emissions, which can be quite significant. And obviously, you cannot have a clean car without its companion clean fuel. And that is really important. And in fact, it's not only the fuel, but the lubricants that can contribute to the emissions that come out of the tailpipe. To get into a little bit of how the standards are set, typically in the US and in Europe, we have chosen, and again, in a future webinar, we can get into the why of that, but we have chosen to set emission standards that are average. They apply to the average of each automaker's fleet. So the automaker will tell the regulators what kind of cars they're bringing, what kind of, the size of the engine, the type of the engine, the emission control that the vehicle has, and then the regulators will determine an average for their fleet. And it is that average that has to be driven down to meet the standards. The next point is important because for those of us that have been in the business of testing emissions in the dynamometer, the standards assume that there is going to be 100% compliance. That is, you put an emission limit, you set the average for each car maker, and the standards are based on an assumption that 100% compliance is going to be achieved. The other thing that is important to note is when you set the emission standards and you utilize a dynamometer and a testing and a procedure that is highly prescribed in the dynamometer, you assume that the world is flat, meaning we don't take into consideration the change in the loading, when the topography changes, for example, in many places around the United States and the world for that matter. The only thing that the standards assume is a degree of deterioration. And there's actually quite a bit of work and research that goes into determining what is the deterioration rate for a fleet of vehicles that are subject to the standard. Now, obviously, in California, from the beginning, there was a recognition that there is going to be consumer demand for aftermarket technologies. And the last point is I think really important, because as I travel to different jurisdictions who are interested in the process in California, the aftermarket regulation that your products may be subject to if you are doing business in California, the only thing that the regulation requires is that there is no effect on emission controls. The aftermarket regulation is not a regulation where you will get a certificate that says you are reducing emissions. And that is often a common claim that I see in many jurisdictions. If you follow the regulation will basically say you can do whatever you want to the vehicle as long as you do not affect its ability to control emissions per the regulation. So that is really the foundation of the aftermarket parts regulation. Next slide, please. So obviously, compliance is really important, and I want to share this most recent paper that I was involved in with some colleagues, my good friend Robin Smith from Australia and a couple of colleagues from Europe. And what we did is basically looked at the published literature. And what we found is that there is still quite a bit of tampering and cheating that is going on. And the malfunctions that the vehicles present are a significant problem for regulators around the world, because obviously I said regulations are put in place assuming that there's going to be 100% compliance. If that is not happening, then there's going to be an erosion in the expected emission reductions that are coming from some of these standards. And clearly, because we are monitoring air quality in the ambient air, those gaps in the emission reductions are eventually going to manifest themselves in the data that we are collecting. And that is why the importance of I&M or PTI programs, as Matthew and Daisy described, that is why they are necessary. Because in the wake of the Volkswagen diesel scandal, the regulators have very much taken an approach of trust but verify. Right? We are not going to be testing every single car that goes on the road, but at the same time, we have the ability to do that. And I think the dealing with the Dieselgate is a great example of how that process works. Next slide, please. We've come a long way, and what I want to sensitize you to here is why we have PEMS. I have a slide here that suggests in the past the only option we had was to take the vehicle to the lab. We had no tools like PEMS to do the testing. Then came the last cheating scandal before Dieselgate. It was the issue that the heavy-duty engine manufacturers got into in the late 90s, early 2000s. And it was then that we regulators spent a lot of time developing and working on PEMS. It was basically to be able to comply with the NTE requirements, the not to exceed requirements that were part of the consent decree, the settlement that the heavy-duty engine manufacturers agreed to before the EPA and CARB. And it was really that regulation that led to what is now known and commonly referred to as the 1065 requirements. They are very stringent. They are very heavy in terms of the requirements that are put on the manufacturers. But I think it's important to understand that we don't need that today. We have much better technology, like the technology that Daisy and Matthew described, where we can take the lab to the vehicle and not only do product development that you may be interested in, but obviously regulators are going to be using the technology in the future coupled with OBD. And the best example is the Euro 7 standards that clearly have the real-world driving emissions, the RDE regulations that really were born out of some of the lessons that we learned from the Dieselgate scandal. And my reference here that we don't need a $10,000 watch is, again, you don't need a complicated, very expensive system. PEMS today have come a long way, and they are very capable technology to give us, the regulators, a sense of performance on the road, but also product developments in terms of, are your products really doing what you think that they're doing? Next slide, please, Dean. And that was my end. Thank you.
All right. Thank you, Dr. Ayala. Let me fast forward us now to our Q&A slide. Okay. So I've been writing down messages and questions as they came across. So I'm gonna take the liberty to send some of these out. So I think this one's a good one to start with, and it's for Daisy. Can the 3DADX parsync be used effectively to capture a cold start from the vehicle along the lines of what is captured in the FTP 75?
Yeah, absolutely. It should be able to capture cold start just as well as hot start behavior. The maximum levels of concentration that the equipment can deal with is perfectly fine for cold start. If you're looking at doing this FTP style, then you would just want to make sure that you divide your sections of your test in the same manner as you would want to if you were doing a bag analysis. And you would need to ensure to have some way of calculating the mass emissions from the concentration values. So the way that we normally do it with our equipment is using the ECU mass airflow method or manifold absolute pressure method. But if you had an alternative exhaust flow measurement device, then that would also be a perfectly suitable way to calculate the mass emissions.
Awesome, thanks. Matthew, I noticed you were mentioning when you were going through the details of the parsync, and you were talking about the particulate canister. You mentioned both PN and PM. Can you explain the difference to everybody and what they might be most interested in the US versus Europe? Oop, I think your microphone's off.
Yes, thank you for the question. Europe has gone down the pathway of PN measurement, where PN is very much used to check the quality of particulate emissions reduction through filters that are placed in the after-treatment system. So if an after-treatment system is working very well, the PN value will be very low. For example, I have a Euro 6 diesel vehicle that I drive, and my vehicle has lower values of particle number from its exhaust than ambient air does just from stuff blowing by on the street. So, I mean, the people at VERT will always say VERT is the organization that developed particle filters, and they'll say, actually diesel engines are cleaning the air now. But, there's still the after effects of Dieselgate, where everybody's worried that diesel vehicles are polluting. But yes, actually, the new particle number legislation and the way DPFs and GPFs are used are very good. Now, if you don't have a DPF in the exhaust, then particle mass becomes very important. because generally speaking, when combustion occurs and you don't filter out the particles, depending on the combustion technology, you get larger or smaller particles that are being produced. Generally, in a clean running engine without a particle filter, you'll see a peak in the particle number around 80 nanometers, which is quite small. After a particle filter, of course, it's much smaller than that. But as the combustion gets dirty, you'll see that peak go up the scale. So measuring particle mass becomes important in those situations, because you can have the same number of particles obviously coming out, but larger particles means more soot, more dirt coming out of the engine. So we have algorithms that from our 3 different sensors that are in the P cartridge, we have algorithms that add them together to produce either a particle number output or a particle mass output. There you go.
Awesome. Thanks, Matthew. I ended up with somebody text in a question, so I'll throw this one in there, and I'll actually take the answer. The question was, how can SEMA companies use this in-house or with their own horsepower dynos, this type of technology? And I think that's an interesting opportunity that maybe answers some questions here. So this is a lot of good information, but what can I do with it? This type of technology in PEMS is bringing the lab to the vehicle instead of the other way around. If you, for those companies out there that have their own in-house horsepower dynos, you can simulate a lot of what happens when you send your vehicle into a formal laboratory. The speed profiles for an FTP, a US06, and an SC03, which are the most common cycles you'll see, those are readily available. We can provide them to you if you can't find them online. Happy to do that. But you can literally set your vehicle up on one of your in-house horsepower dynos, set up PEMS on the back of it, and start logging some of your own information. Now, you cannot yet use that for certification purposes, but that is a nice way for you to understand a baseline versus modified configuration and what type of impact your product has on those tailpipe emissions before sending it in to the laboratory. So hopefully that helps whoever sent that text message in. And then let me ask one more question to Dr. Ayala. And maybe a little off topic, but I think you have the right audience here. So the question is, Dr. Ayala, as aftermarket manufacturers, we deal directly with the aftermarket parts branch at CARB and must interface with those regulations. We often experience frustration due to delays. I know you're no longer with that organization, but do you have any advice for how to ensure the smoothest processing with CARB?
No, that's a great question, Dean. And I appreciate the question and can share with you all candidly. Just for reference, when I became deputy at CARB, I was overseeing the mobile sources, the mobile source programs, and one of them being the aftermarket parts regulation. So I'm very familiar with it. I'll say 2 things, and again, very candidly, since I'm no longer with the organization. I think if I think back in terms of what was causing delays, and I know there is frustration when you're the one trying to move your product along, incomplete information, right? Oftentimes regulators are asking for information, again, whether you like it or not, but they're asking for information. I would say the first thing is make sure that you're providing that information on a timely basis. A lot of the delays were just simply because we had one of our engineers that was in charge of whatever product you are attempting to certify. We just didn't have information. There's a lot of waiting in that regard. The other thing, and you know, the obvious thing, every agency in the U.S., not just CARB, is under resource constraints. But the other advice that I give folks today is be resourceful. Don't forget, if you need to, elevate it, right? I mean, oftentimes the staff that are looking at your application are probably looking at 1,000 other things. And if you want to get in front of the line, you got to get in front of people. And what I mean by that is, I oftentimes, as a deputy, I had people come directly to me and say, hey, you know, these are the pressures that I'm facing. You know, can you help us? And that is important for you to recognize. Have people that understand how to navigate the agency and get to the people in charge. Because for us, when we get an application for one product, we treat it the same as the others. And that may not be the case for good reason. I mean, you all are facing different requirements. The agencies do not want to be a bottleneck, right? But what I would advise you is, again, be resourceful. If you need to elevate it, you're working with the right staff, but there's people that they report to that can make maybe restack the deck and put you at the front of the line. So don't forget that.
Thank you. I know that was a little off topic today, but like I said, this is the perfect audience for that answer. So thanks for that. I'm going to wrap up the Q&A there, and we do have a couple additional comments that I'd like to leave everybody with, some opportunities. First, we have some test opportunities with PEMS at SEMA. We're actually looking for 3 manufacturers who are interested in participating in PEMS demonstrations, and this can be for product testing in-house. If you're interested in participating in that, contact emissions@sema.org. Just give us a brief message with your contact information and what type of product you're interested in testing in-house. I think that'll give a lot of folks an opportunity hands-on to work with a PEMS unit for those that have never dealt with them before. Next, well, we do have a PEMS unit here at SEMA, so that offer I just made for 3 manufacturers that are interested, we actually have a PEMS unit. And if you're not one of the 3 that are chosen, just know that we still have this unit here. It's available whether you want to use it here on site, or if you want us to ship it to you and train you how to use it. That is an open resource to you. If you want to, test before you buy, if you're ever interested in actually making such a purchase, this could give you an opportunity to at least expose your staff to this type of technology. See how either complicated or how simple. And I will say from personal experience, this technology is more simple than it has ever been. We used to be very intimidated by this type of thing, and it's very easy to use now. So additionally, if you can't reach out in the meantime, but you're going to be at the SEMA show, we will have the 3.x hardware and the team on site at the SEMA show in the Future Tech booth, which is in Central Hall, booth 24401. So it's in I think that's the northeast corner of the Central Hall. There will be a green 911 Porsche next to it, or actually being operated with it. So if you'd like to actually schedule a meeting or a chat beforehand, reach out to support@3.x.com and they can help you set up a chat, or reach out to us at SEMA and we can make sure that it happens. Last 2, we've got 2 panel discussions coming up at the SEMA show on Tuesday and Thursday. The Tuesday session is called Emissions Reality Check, Navigating EPA and CARB Compliance in the Trump Era. That's under legislation 1, if you're looking it up in the attendee guide. And then the Thursday session is called Lessons from the Frontline, Building Success Through Emissions Compliance. And just to back up 1 second, but on that Tuesday panel discussion, Dr. Ayala will join us for that panel discussion as well. He'll give us some additional perspective from a regulatory side. We want to understand more about why are we doing a lot of this, and it seems onerous or costly or time consuming, whatever. We need to understand the why behind it, and it'll make us more effective at solving whatever the solution or problem is in front of us. So anyways, I wanted just to lastly thank everybody that's participated today during this during this webinar. We're, I think, representing at least 4 countries that I know of right now. On the call today, obviously we had some folks from the US. We had a representative from China, Slovakia, and the UK. So I appreciate everybody's time. I'm sure when we hang up here, we'll have some people go to sleep. We'll have some people that are waking up. And anyways, thank you everybody for your time today. I hope it's been informative. And if you need anything else, please reach out.